Space-time back and forth? Time moving forwards and backward in Planck time intervals? It is a legitimate possibility in physics since matter and antimatter are identical in every aspect but mirror each other. Electrons, positrons, and other particles oppose each other as matter and antimatter. I argue that empty spacetime acts as two mirror fields, causing matter to behave like antimatter. The same matter in the opposite spacetime field, reverse time, acts as antimatter. As time progresses, a Mobius-like shape moves forward, and a 720-degree rotation needs to come back to its original state. These back-and-forth rapid flips cause all matter within our universe to be cut into quanta or packets, showing packets and wave characters. While in the backward arrow of time, everything flips and is shown as antimatter. Spacetime does not advance in time in one direction only, as its fields change backward and forward as frequently as Planck time. Time remains constant, only changing directions rapidly between positive and negative, past and future. Meaning time goes backward and forward, while matter within this space-time also mirrors itself. However, matter moves forward in our time-space universe towards the future since we can add all the Planck times in positive space-time intervals. We are sensing in our mind only the positive spacetime intervals. Our universe is the sum of the positive side of spacetime, while there is another parallel anti-universe with antimatter in negative spacetime. These two universes never meet and move parallel to each other. We don't notice the mirror universe in which our mirror self exists since the present time is only one Planck time. Next Planck time will be the future and previous is already in the past. Since our mind can only sum the matter and not antimatter, we are not aware of the parallel antimatter mirror universe. From a physics point of view, we exist only in a single Planck time, and the sum of all Planck time intervals gives us a sense of the arrow of time. This, I claim, is the cause of both quanta and the wave nature of particles. In Planck time, any wave energy is divided into quanta or pixels, Planck timescale, of rapid spacetime intervals. This could also explain the entanglement problem since each pair of particles is created within the opposite spacetime field. If we conduct a thought experiment and freeze a single Planck time, that size would be that of a photon as a particle, quanta, and no wave behavior is shown since it requires more Planck time intervals to manifest as a wave. A photon doesn't feel the passing of time as we do, as time flips back and forth, but in total from a photon's perspective, time remains constant, and the limit of light maximum speed is caused by the limit of intervals flips between time fields, which depends on the energy. The next Planck time would be in reverse time, causing this spacetime to flip over as well. The wavelength is determined by the energy that drives the speed of the time flipover, where more energy leads to shorter waves. From our perspective, the next Planck time corresponds to our universe, positive time frame, and we feel the sum of all preceding favorable Planck time intervals as time flows into the future. Meir Giladi, Israel.